So we're going to get started. If you haven't installed Git already, it's okay. It's going to be a couple of minutes until we actually start doing anything with it. So my name is Zachary Shiner, and I'm going to be presenting the GitHub and Git workshop at ShellHacks 2020. This is so weird not giving it in person, let me tell you. So let's start by explaining what Git actually is. It's something called a version control system, which allows you to track changes and allows easier collaboration on different projects, such as keeping multiple versions of a project. You can also store the history of projects, and it basically helps you keep track of everything everyone's doing in a project. So GitHub itself is an online website and web service for Git projects. You can add people, huge collaboration on large teams. You can have backups of all your projects. And if you haven't already, you can create an account here at github.com. We'll be using that later. So why use Git and GitHub? Besides it being just an industry standard for version control, because there are many different alternatives out there, but Git is pretty much the de facto. All your code, your bugs, your documentations, it's all centralized in one place. You can keep different branches of code. We'll go over that a little bit later in the workshop. You can tag significant releases. You can store the entire project history. These are just some of the basic things that you can use with Git and GitHub. So before I actually get started, there's a couple of vocabulary terms that you should learn, such as repository or repo. We'll be saying that a lot. It's a place where resources are stored. So when you commit code to a repository, that's basically you just storing the code there. A commit is a snapshot of your repository. So it's like a slate of what your repository looks like at a given time. We have something called origin, which is just the URL of a remote repository. We have upstream, which is the remote repository that we push to. And we have something called master, which is the default branch in a Git repository. Something else that you should learn about is something called Git Trees. And this is like the backbone of how Git actually works. So we have a working directory, which is where your most recent uncommitted, unadded changes are stored. So if you have a repository and you're working on code and you haven't fully committed it or pushed it to a repository, this is where it'd be located in your working directory. Now, once you actually add it, so when you're preparing to push it to a repository, you're going to put your code in something called the index or a staging area. And then from here, you can commit your stuff to the head. A head is just a little pointer that points to the last commit made. So the whole process behind working on a project with Git and GitHub is you have your working directory, you add it to the staging area, and then you commit it to the repository. So if you haven't already, these are the instructions to install Git. I know a lot of you said yes, so we're just going to skip over this. So now we can actually start using Git. So when you downloaded Git, you should have also gotten something called Git Bash, which is a terminal, pretty much. It's going to look something like this. I guess I can zoom in the text. And what we're going to do is once you have this Git Bash terminal opened, you're going to need to link your GitHub account. So you can use that doing git config. You can use this global tag. Not really, Corey. It's just another kind of terminal. If you installed Git correctly, you should be able to access it via any terminal. I'm just going to be using Bash since it comes with Git for this workshop. If I do git config, I see I have a bunch of different options to choose from. What I'm going to be using in this -- global flag, which means that this user email and this username I'm going to be setting can be used in any repository. So if I were just installing this for the first time, I would do something like git config global user.email. And then I'd put my email here. And this would link my email that I use with GitHub to this git config. And then the same thing, I would set my username. Give you a couple seconds. Let me know when y'all have set up your config for Git. Perfect. We are going to get to that, Corey. So now we are going to create our working directory that we're going to be storing code in. So for me, I'm just going to go to my desktop and just create this folder here, but you can place this folder anywhere on your system. And so if you're not familiar with terminals, you can create a folder pretty easily by using something called make directory or mkdir. And I'm going to call the folder learning Git, if I can spell it right. You could theoretically name this folder whatever you want, but for the sake of the workshop, I'm just going to call it learning Git. And then once that's done, I can go change my directory into this folder. So now if you notice, my path is in desktop. I'm in a folder called learning Git. Everyone following so far? Cool. So now we have a folder, but we need to create our local repository inside this folder. So we're going to use a new command called git init, which is short for initialize. What this is going to do is it's going to create an empty Git repository inside this folder. So if you're using the Git bash terminal, you should now see this blue text here called master, which is telling you what current branch we're in. We'll get more into that later. But the most important thing is that now inside this folder, you're not going to see it with ls, but if I go into this learning Git folder, I now have this folder called .git. And this symbolizes that we now have a working repository at this directory. So now we're going to log into our GitHub account on your browser, and we're going to create a new remote repository there. So the steps to follow that are like so. Are you guys able to see Chrome instead of the PowerPoint now? All right. So there's going to be a green button up here, or you can go to the top right and do it this way. But we're going to go new. And we're going to name it, I'm going to name it the same, just learning Git. Give it a little description. Let's call it repo for learning Git. There's a couple options down here. We're going to ignore all of them for now. You can set it to public or private, depending on if you want other people to be able to see what's inside your repository or not. I'm going to make mine public, and I'm going to click create. So now at this point, we should have a local repository that we made on our system. And by doing this, now we have a remote repository that's hosted on GitHub. As of right now, the two are not linked, so that's going to be our next step. And if you actually look at, you should come on to a page like this after creating a repository. It'll give you the steps on how to link this to a local repository. So here's what we're going to do. Now we're going to connect our local repository to remote, and we're going to use something called a remote in Git. A remote is basically a link between the two repositories. So what we need to do is we need to actually get this URL from GitHub. We're going to go to our terminal. We're going to do git remote add origin, and we're going to paste that link in. You can name this remote anything you want. It's just usually standard to name it origin. So git remote add origin, and then the link to that repository. And now once that's done, we can use that remote to push and pull the resources from the local repository to the remote. Everyone successfully create the remote. Awesome. You can tell if it worked if it didn't spit an error message at you. Git is going to be one of those things that you use where it's not going to tell you if something went successfully, but it's going to yell at you if something went wrong. So like, for example, if I did git remote add test, and I have like an invalid URL. Actually, no, that worked. I guess if I tried to use it, it would try to spit an error at me because it's not a valid URL. So aside from that, now let's start adding stuff to our local repository. So I'm just going to add a simple text file. You can use VI if you want to stick specifically to a terminal, or if you're using Windows, you can open up and then just go new text document. I'm going to name mine sample. And I'm just going to go here, and I'm just going to put hello ShellHacks 2020 and save that. So now inside my local repository, I have a single text file. And in your cases, when you start working on your projects, you would start inputting your code into this folder. So once that's done, we're going to use a command called git add. And if you remember from before, git add is going to stage everything that we put inside this repository. We use the dot to symbolize everything in the folder. If I had multiple files, for example, I could just do git add sample.txt. But for now, we're just going to use the dot. And now we just staged our text file. So it's not fully committed to the repository yet, but it's one step closer. So to actually commit the changes, we're going to use a command called git commit. And the way this works is we type in git commit -m, and then we can give it like a little short message. So I'm going to say for mine, initial commit, because that's what it is. It's my first commit to this repository. But you could put anything into here, like fixing bugs or cleaning code or added method. You could put whatever you want in here. But just make sure to surround the message in quotes. And after that, we should see one file changed, one insertion. If you're using, are you using VI, Sydney? Okay, so if I do vi sample.txt, pressing I allows me to edit. And if I'm done, I'm going to press escape. I'm going to hold shift and go to colon, and I'm going to type in WQ at the bottom here. And this symbolizes W for write, that means save, and Q for quit. Awesome. Let me make sure I didn't add anything. Okay. So let's go ahead and commit our text file. We're going to do git commit. Oh no, we just did that. My bad. Yeah, let's sidetrack. So the file's committed, but it's still in the local repository. If I tried to go to the repository made on GitHub, I'm going to find that there's nothing in here because we haven't pushed it to this remote repository yet. So in order to do that, we're going to use another git command called push. So the syntax is git push-u. Origin is the remote we just made, and master is going to specify the branch. So let's go ahead and do that. Git push-u origin master. And it should give you a couple messages. And yep. Now, if we go ahead and take a look at our remote repository refresh, I can see my sample text here, which says hello ShellHacks 2020. So to go over what we just did, we created our text file, we added it to the staging area, we committed it to the local repository, and then we pushed it to the remote repository. Everyone see their text file on their GitHub repository? Y'all are on point with this. So this command can be a little lengthy to do over and over and over again. So what Git does is after your first push, it's going to save the remote and the branch for you. So in future pushes, all you need to do is git push. For example, if I go into I'm just going to add a simple sentence here. And then I go through the process again. And I just do git push. It's going to work without me having to specify the remote and the branch to push to. So looking into here, I now see the second line I just added. So now is a good time to start explaining branches a little more in depth. I've been mentioning them a little bit before. Branches are your way of storing multiple versions of the same project. So generally, your default branch will be master, and that's where your most stable recent version of your code will be. So let's say I'm creating a web app that displays some data from a data set, and I get a working version of it. I'm going to put that into my master branch. But then let's say I'm working on it with 5 other team members. All the changes that we make, we may not want to initially push to master until we know for sure that they're completely working. So we could create a separate branch to put that information in and then later merge that with master. And you can have many different branches. For example, in this diagram here, we have our master branch. I'll have something that I'm working on in isolation, and then maybe one of my teammates will have their own branch that they're working on. And then eventually we'll all merge these into master. So this is at its core how version control works and how many different team members can collaborate without messing each other up. So let's go ahead and make a separate branch in our current repository. So right now we only have master, and we can see that we're in master because of this text here. So we're going to use something called checkout. Checkout is originally used to change between branches, but this -b flag here tells Git that we want to create this new branch. So we're going to do git checkout -b, and I'm going to call this branch feature. You can call it whatever you want, as long as it's within the quotes. After running this, I should see switch to a new branch feature, And now my path here, now instead of saying master, it should say feature. Everyone got this working? Awesome. So now anything that we change within this feature branch, when we do the git add, git commit, git push, they're only going to be pushed into this branch here. And anything in master will left untouched. So I'm going to go into, I want you to modify your repository in any way you want. You can add a new file. You can modify your original text file. I'm going to modify mine to say, instead of I am in master branch, I'm going to change this to I am in feature branch. So if we look at what we have to do, we have to go through that process again of git add, git commit. So let's go ahead and do this. Remember that our command to add, the first thing we have to do is we have to add the files. Don't worry about this warning. It won't really affect your text file. And then we're going to do git commit dash. In this message, I'm going to say new branch because we are pushing this text file to a new branch in our repository. If you're in insert mode, press escape, and then you're going to do shift : and WQ. So I'll show you. I'm in insert mode here. I'm going to press escape. I'm going to do : colon at the bottom here, WQ to quit and save. Or if I just wanted to quit, I would just put Q. So let's do our commit now. I'm going to say new branch. And after committing, now we need to push. Remember before how we did git push -u origin master. Now instead, we're going to push to this feature branch. And since we're doing a new branch, instead of just doing the shortcut git push, we need to add the -u flag, the origin for our remote, and the name of our branch. And I'm going to go ahead and push this. And now, if I go ahead and refresh my repository, I should now see here I have two branches. I have master and I have feature. And you can quickly go between them by this button here. I'm going to go to feature. And this text file says, hello, ShellHacks 2020, I am in the feature branch. Where in master, it says, I am in the master branch. Everyone see their new branch on GitHub? Awesome. So now, let's assume we've been working on a project for a while, and we have this feature branch that we've been adding changes to, and now we're ready to merge it with master. Meaning we want to take all the changes that we put into this branch and add them to the master branch. We're going to use a command called git merge. And what this does is you need to check out to the branch, your source branch. So for example, we want to add everything from feature into master. So we need to check out into the master branch and then run this git merge command. So it's git merge and then the branch that you want to pull the changes to or merge from. So in this case, we're going to do feature. So git checkout master. We don't need to do the -b now because we're not creating a new branch. We're just switching. And I'm going to do git merge. So because I have the same text file, but I just changed it, it's going to say one file changed, one insertion, one deletion. So now the contents of feature are now in master. We just need to actually push them. So we're going to do git push -u origin master. So we should, because we did a merge, we don't need to add and we don't need to commit. We just need to push. So now if I go to GitHub, I refresh this, and then if I look inside master, my sample text now has what I wrote inside the feature branch. And if you added a new file inside your feature branch and then you did the merge, you should see that new file inside this master branch as well. Any change that you made will now be reflected in this branch. Everyone following? Dope. And you can imagine when working on a project, you may have multiple different branches. I know that for some of my projects, I'll have a branch dedicated to just GUI changes, another branch to just backend changes. It really helps you stay organized, especially when working in a group project. Everyone knows where all the different changes they're making are without interrupting each other. So now we're going to look at something called git log. Remember how I said earlier that Git allows you to store the history of your entire project? This is how you view said history. If you do git log, I'm going to be able to see all the commits that I previously made for this repository. And if you notice, earlier I talked about a head pointer that points to the latest commit. So your last commit, you're going to see this head pointer. And you're able to see, okay, who pushed it, what was the time and date that they did, what comment did they add for the push. And then you should have a long string of characters here. This is going to be something called your commit ID. Every commit that you make will have its own unique ID, and that's how you can reference it. And there's all sorts of different commands that you can do with log. So if you do git log --help, it's going to open up this HTML file. And this is going to tell you all the different things you can do with the log. I'm not going to go over them all, but if you are interested, I recommend just going through this, especially once you start working in a repository that's maybe, a couple months old with a bunch of commits. So we're going to use the git logs to start tagging our commits. So let's say earlier in our scenario, we merged feature with master. And the scenario I came up with is we added all of the changes to our project we did in feature, and we were ready to add them to master. Master is now a stable release we are ready to put out to the public. So we can give that commit a version tag. Oops. So the syntax is git tag. You would put some number like this. If it's your first release, you'd probably do something like 1.0.0. And then you need to put the commit ID. So I'm going to look at here. I'm going to go to my latest commit, which is where my head pointer is at, and I'm going to copy that ID. And then I'm going to do git tag this, and I'm going to paste that ID here. And if it doesn't yell at you with any errors, it probably worked. Once you're at this point, we are ready to push the tags to GitHub, to your remote repository. So the way you do this is a little different than pushing files. You do use the git push, but all you need to do is add this tags flag. And Git will automatically push any new tags that you created to the repository. Since tags are not branch specific, you can just push them without specifying a branch. So we should see total 0 because we did not add new files, but we should see a new tag here. Which means if I go to GitHub, my remote repository, and I refresh it, I should see 2 branches, and I should also see 1 tag here. So whenever you look at a repository and they have tags, you can look at, oh, what's this 1.0.0? And this is going to tell me this was the source code that was pushed under this tag. So this is how you version out different versions of your code. You know, the difference between version 1.0 versus 2.0, or maybe 1.1.0, depending on the updates and changes that you make. This is just another neat little trick that Git and GitHub use to help you organize your code. Everyone get their tags uploaded? Awesome. So now so far we've gone over, you have to right click. You can't control C, or you can control C, but you can't control V. So a right click will post it. That work for you, Timothy? Awesome. So far we've gone over how to create your own repositories and how to push updates. Now we're going to look at, let's say there's an already existing repository and you want to start working on it yourself, like you just get added to a team. So what we're going to do is, I have this link here. I'm just going to go ahead and oops. I can go ahead and put this into chat as well. This is a repository that I made specifically for this workshop. So what I want you to do is we're going to take that URL that I just put in chat and we're going to clone it. So at this point now, we're done with learning Git. We can just go ahead and leave it. I'm going to go back to my desktop and I'm going to do git clone, and I'm going to post this in. And this, what this will do is this will create a new folder of whatever the repository name is. In this case, ShellHacks 2020 GitHub Workshop. And it's going to pull everything from those repositories into that directory. So now, if we go ahead and change our directory into it, now look at all the files, we should see 2 files in here. One is a text file and one is something called a README. I'll touch on READMEs very briefly. They're used to give a description of your project. So when you load a repository, this README file is what shows up here. This is what people see. So this is just a basic example of one. It has a title of the repository name and just a brief little explanation of what's going on. And if I go ahead and open File Explorer, here we go. Something that LS won't pick up is something called this .gitignore. We'll talk about that in a bit. Has everyone successfully cloned the repository into their system? And if you're snooping around, they should say something like, imagine this is really cool source code. I already showed you the README. This gitignore has some stuff here. I'll explain that in a second. So something really cool about this is the repository I had you clone has multiple branches. We have a master branch and we have a development branch which has an additional file called development.txt. And so what we can do is if we do git checkout development, if we change to this new branch, I should now see this development.txt file in here. So now I'm viewing all the content of the development branch instead of just looking at what was inside the master branch. So if you ever find yourself needing to switch between different branches, this is how you would do it. And then everything in the directory should reflect what's inside the current branch you're in. Everyone able to switch the branch and see this development.txt file? Yeah, you can. Exactly, Sydney. We use git checkout to switch between branches, and if we ever wanted to create a new one, we would just add a -b here. And then we put name. So if I wanted to go back to master, I would just do git checkout master. We're gonna go back to development. To answer your question, Chris, I use VI most of the time to just open and see files. But there's all sorts of other ones. If you want to stick to a terminal, there's VI, there's gedit, or there's your normal just text editors that you can use. So as you're working on projects, you'll be cloning a repository or setting up a repository in your system and pushing changes. But other people, if you're working in a group, will also be pushing changes. So there might come a time where the repository on your system will be outdated compared to the repository on GitHub. So all of you just cloned my repository. So if I were to add new files to that repository, you would have to pull these changes. And we use git pull, and then you can set a flag to just pull everything. So if I were to try to do it now, I'm going to get a message saying already up to date. But hypothetically, if someone else added new files to that repository and I did git pull --all, I would pull all of those changes onto my system. So I would be syncing the two repositories. So now let's talk a little more about this .gitignore file. So if we look inside here, I have this .gitignore. And the one in development only has .dat and creds.txt. So sometimes when you're working on a project, you may generate additional files or use additional files that you may not want to be public on the repository. So you can use .gitignore so that when you do your git add, git commits, it'll ignore these files. So for example, me adding this .dat here, let me zoom in. What this is telling me, since it's inside this gitignore file, is any file with the .dat extension, ignore them. So that way, when I do commits, I don't have to worry about, okay, what files do I need to ignore? I can just toss them into here and Git will handle it for me. So you can do file extensions. You can do specific files. So this gitignore is ignoring a text file called creds.txt. And actually, I'm pretty sure if I go back to master, and I open this gitignore, yeah. So you can do file types, you can do specific files, and you can even do entire folders. So inside master, this gitignore file is ignoring a folder called bins. We specify it's a folder by adding the slash at the end of it. And there's entire documentation on gitignore because it goes really in depth and can be a really powerful tool for protecting you from, let's say, accidentally publishing sensitive credentials to a repository. or maybe you have a keygen that you don't want out there. Does that make sense to everyone? Awesome. Actually, what I can do is, if you are curious, I'm going to post the link to the documentation for the gitignore file that you can look at if you ever need to create your own. So now we're just going to go over some additional features that GitHub has that can give you even more control over your repository. Yep, Brian. If you use just a dot, it would probably ignore everything. So that'd be kind of counterintuitive. Although I am curious if Git has any protections against that. That might be something cool to try out. I've never tried that though. Exactly. Okay, so let's go over some key features that GitHub has. So if we look at the slide, there's something called issues. And what we can do is we can go to this ShellHacks GitHub workshop. And if we look at this top tab, there's a whole bunch of options. So we're just going to go over a couple of them. The first one I want to go over is issues. So a lot of times people will create open source software or programs that they'll host on GitHub. And let's say you are trying to use it and you come across an error or a bug. What you can do is, either as a developer or as just a guest on the repository, we can create a new issue. So I can just name this one, there is no code in this repo. So this allows you to keep track of all the different issues and bugs that are currently in your repository. So anyone, if you refresh the page and go to issues, you should be able to see this issue I just made. And then as you go along and you make changes and upload more files and changes to your repository, maybe you had an issue and you fixed it. In that case, we can go edit. Or no, this will just stay here. But eventually, you know, there would be an update to this where you would say fixed or whatever. The next one I want to talk about are pull requests. So pull requests work similar to merges, except it's a GitHub function instead of Git. They're essentially the same thing. So if we look at GitHub, I wanted to make a new pull request. This is basically GitHub's way of merging branches without having to go through Git itself. So you can do this straight from the website, if that makes sense to everyone. Because before we'd have to go to the bash, we'd have to do git merge and then the branch name if we wanted to do it through Git. But if we wanted to just do through GitHub, we can just use a pull request. And then there's also something called forks. So let's go ahead and look at here. So forks is going to be all the way in the top right corner here. And what this allows you to do is it basically copies this repository onto your account for you to start building upon. It's almost like a clone, except it works to your GitHub account. So let's say I was not logged in. I was a different user looking at this repository. I could fork it, and then it would copy it to my GitHub account. So you guys can actually try that if you want to fork it to your GitHub account and see what happens. It's a lot, I know. This can be really useful if you are working on a similar type of project to someone else and you don't want to use their repository as a starting point. This would be something you would do. So I see some of you are starting to fork it. So since I'm the owner of this repository, I'm going to sit here and put y'all on blast and leak your GitHub usernames. So I can see everyone that forks this repository. You're not slick. And if you guys look at your repositories, you should see the copied repository under your list for everyone that forked it, right? Exactly. What Dohan said. There's a whole bunch of other tabs here, including actions, and there's going to be an entirely other workshop dedicated to just this. I highly recommend checking it out. Nike, I hope I'm sorry if I'm butchering your name. Are you talking about when you're pulling updates? Or are you talking about after forking it? If you wanted to sync, you would probably just have to fork it again, because the whole point of forking is to copy a repository to start building on it yourself. If you wanted to stay updated with the repository, you'd be better off cloning it and just continued pulling updates. That would be the better option. Best practice for merging issues. Uh, it is being recorded. So merge conflicts are a tricky thing to figure out because there's many different issues. A lot of times what it comes down to, I need to prevent merge conflicts. Uh, just be careful with how you update files. So if you do end up coming across a merge conflict, a lot of times you'll have to fix the conflicts manually. So this workshop is being recorded and will be posted on the UPE YouTube channel. So if you do have a merge conflict, I guess I can pull up an example. Let me see if there's any good Google images. So something like this. Literally, merge conflicts are a pain. So I'm showing an image here of an example of a merge conflict. Honestly, most of the time you end up having to fix these by hand. They just kind of happen, especially if you are constantly updating files. You may come across one, and they just suck. There's no going around it. They just suck. So Git has some pretty good tools that you can use to compare different files so that you can figure out, okay, what do I need to fix? But yeah. So I am going to post these links into chat. They are basically just further learning for GitHub and Git. Oops. Let me open this up. So this workshop just went over the basics of Git and GitHub. And if you want to learn more, there's going to be another Git Actions workshop. And you can also go to these links, which are really good. No, I'm not going over GitHub Actions because there's another workshop on it. I don't want to double cover something that an entire workshop's going to be talking about. If you look at the schedule on Hopin, it should tell you. I'm not exactly sure the exact time. I can look real quick. But yeah, that's going to be the end of this workshop. If you guys have any questions, I'm going to be here for a couple more minutes until 12. But okay, so yeah, the workshop starts at 12, right after this. This workshop's going to be posted on the UPE YouTube channel. No problem, Sydney. So I'm going to leave this, and I'm going to go back to the learning Git repository that we were working on. So do you need to create new branches for every new issues? Not necessarily. Sometimes you do, if it's just too much to fix by hand. But if it's a small issue, you should be fine. So yeah, Daniel, this next workshop would be perfect for you. So back to Sydney, you wanted me to go over Git merge. So if I look inside this master branch, I just have a single text file called sample.txt. And if I go to the feature branch here, and I do, let's go ahead and change this text file. We're going to go to learning how to merge. Now this sample.txt file is different inside the feature branch than it is in master. So if I wanted to merge them, I'm going to first check out to the branch that we want the changes to update in. And I'm going to do git merge feature, where instead of feature, you would have whatever branch you want to merge with master. And this works the other way around. Maybe you want to update everything from master into feature, where in that case, I would go into the feature branch and do git merge master. Awesome. Any other questions? Sure thing. Yeah, we got 5 minutes until this workshop technically ends. So first things first before tags is we need to understand how git log works. So if you notice, when you do git log, you'll see every commit ever done on this repository. And we need something called a commit ID, which are these really long strings of characters. So if you look at this commit here, I already have a tag, but let's say I want to add another tag. I would need to copy this ID. I need to do git tag. I'm going to call this 2.0. And I'm going to paste that tag or that commit ID in here. So I'm saying for this commit ID, I'm adding the tag 2.0.0. And once I add the tag, it's just a matter of git push tags. And then after pushing it, you should see that the new tag has been pushed to the GitHub repository. No problem. No problem, Stefan. I'm glad you came. I hope you learned something. Happy hacking, everyone. how to delete my commit, your commit. So there should be something git reset. I think it's something like that if you want to delete a previous commit, where this will delete the very last commit. That answers your question, Nate. Okay. Thank you so much. Good luck with all your projects. Can't wait to see them. Have a good night. Why am I kidding? No one's getting sleep this weekend.